Hello and welcome back. Today we'll be doing question 3 from the 2008 STEP paper 2. So, let's get started. Question 3, part 1. Find the coordinates of the turning points of the curve y equals 27x cubed minus 27x squared plus 4. Sketch the curve and deduce that x squared, 1 minus x, is less than or equal to 4 over 27 for all x greater than or equal to 0. Given that each of the numbers a, b, and c lies between 0 and 1, prove, by contradiction, that at least one of the numbers b, c, 1 minus a, c, a, 1 minus b, and a, b, 1 minus c is less than or equal to 4 over 27. Part 2. Given that each of the numbers p and q lies between 0 and 1, prove that at least one of the numbers p, 1 minus q, and q, 1 minus p, is less than or equal to 1 over 4. Pause the video to have a think, and once you're ready, restart to see if you were correct. So, let's get started with part 1. So firstly, we will differentiate to get y prime is equal to 81x squared minus 54x, which is equal to 27x, 3x minus 2, which we want to set to be 0. Solving this gives x is equal to 0, or x is 2 over 3, and substituting these back into the original equation gives y equals 4, or y equals 0. We can now sketch our graph on the right, and we should know by now that this is the shape of a general increasing cubic. The turning points will of course be 0, 4, and 2 over 3, 0, as shown. Now, from the graph, we have that y is always greater than or equal to 0 for all x greater than or equal to 0. Therefore, by rearranging, we can arrive at x squared minus x cubed is less than or equal to 4 over 27, and therefore x squared, 1 minus x, is less than or equal to 4 over 27 for all x greater than or equal to 0, as required. For a proof by contradiction, we shall assume that all three expressions are greater than 4 over 27. That is, BC, 1 minus A, AC, 1 minus B, AB, 1 minus C, is greater than 4 over 27 all cubed. However, that expression is equivalent to A squared, 1 minus A, B squared, 1 minus B, C squared, 1 minus C, which is less than 4 over 27 all cubed. And therefore, by proof by induction, one of those three must be less than or equal to 4 over 27, as required. Now we can move on to part 2. For part 2, we shall use a very similar method. Firstly, we'll choose a quadratic function to find the maximum of. Here I've used x minus x squared, however there are other possibilities. For x minus x squared, the maximum value between x is 0 and x is 1 1/4. And therefore, similarly to part 1, we can see that we have p, 1 minus q, q, 1 minus p, is greater than 1/4 squared, to set up the proof by contradiction, but also that is equal to p minus p squared, q minus q squared, which is less than 1/4 squared, and therefore, by proof by induction, one of the two is less than or equal to 1/4, as required. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.